Hello class. So the other day we were trying to look at the operational amplifier, and when it comes to the amplification, we kind of said there's a math behind it, and we were trying to put some math together, and we had some trouble. So I decided to create a video on it and to give you some explanation behind it, right? So I have a script here on my other screen here, so I'll just go line by line and then explain the things behind it, so that I don't miss any points, right? So the first point that I have is that the primary usage of the operational amplifier is to amplify the signal. So that part you guys probably know it by now, right? And one of the simplest op-amp configuration is to do that is the inverting amplifier. So that is the simplest way that we can do the amplification. So this configuration uses two resistors to provide divided feedback to the operational amplifier. Okay, so I'll explain what that really means. Okay, and it's called an inverting amplifier because the output signal will be negative or the flip version of the input signal scaled by some amount. So we talked about it the other day in class, right? So when it comes to amplification, the shape and the size will be changing, right? So I don't know if I really want to put that once again. So if that's the input signal that we have, right? And the output signal on an amplification, the output signal will, inverting amplification rather, the output will be something like this, right? So what happened here, the shape and the shape in the sense this shape got inverted as well. The peak to peak has also changed, right? So that's why we call the um, inverted amplification, right? So here, one of the resistor connects to the input signal, right? And at the inverting, so we have the input signal inverting resistor here. So we have a resistor here, and the negative. So we have the inverting. The resistor is connected to the inverting terminal, and the other one is the feedback resistor. So let's call this the R in, and then let's call this the RF, reference resistor, right? So RF provides feedback from the output of the operational amplifier back to the input term, non-inverting amplifier, right? So this is going to be providing feedback to the inverting input, right? The non-inverting or the positive terminal is simply connected to the ground. So this one, non-inverting, is connected to the ground, which is going to produce how much voltage? 0 voltage, right? The inverting amplifier closed loop voltage gain. So this is the closed loop. We talked about that too. Whenever we have a feedback that goes back into the non-inverting input, we also always call that closed loop. So in this case, the voltage gain, which the ratio of its output voltage, right? So the ratio for the gain that we looked at is the reference resistor divided by the input resistor. So this is the gain. So for example, we took some resistors in place. So in this example, let's say the input resistor we take upon, let's say, R in is going to be 10 kilo ohms, right? And then R F is going to be 100 kilo ohms. Okay, so let's pick up that example, and then let's say we have a 5 voltage supply here. Okay, at the voltage, this is going to be our voltage in, right? Okay, so with this example, first calculate what is the current over here. So I is equal voltage divided by resistor. So we have 5 divided by 10 kilo ohm, which will provide 0.5 milliamps. Okay? So the current that we have here is going to be 0.5 milliamps. And then which Kirchhoff law, the voltage drop, after the voltage drop across the resistor here, we have zero voltage here. Okay. Now the thing is this: the second golden rule of the operational amplifier is actually the first golden rule. Let's take up a first golden rule first, right? So the golden rule of the operational amplifier: any current that comes over here will not pass through this point, it will go in this direction, right? So that is rule number one. Now if that's what the case is, if the current is going to go through this way, we have zero voltage over here is fine. Now the objective of the operational amplifier in this case is to maintain 0 volt at these 2 points. Because we have 0 voltage at the ground, the operational amplifier always try to make 0 voltage at the inverting input as well. That's a duty, right? So in order to do that, the feedback resistor need to do something. So we have a current that goes on this direction because the current cannot go in this into the operational amplifier, and in order to maintain that 0.5 milliamps current, right, with the 100 kilo ohm resistor, which is right here, how much voltage is supposed to be dropping across this resistor, right? So that is our next calculation. So the voltage is going to be 0.5 milliamps times 100 kilo ohms, right? If that's what it is, it'll be 50 volt, right? So there has to be a 50 voltage drop across this resistor here, right? Across this resistor here, in order to maintain that zero voltage. So if that's what it is, the output has to generate 50 voltage. But the problem is this is a feedback, right? If this is a feedback, it has to be negative 50 voltage, right? It has to be, where is it here? No, that. So, sorry, I messed it up. Let me erase it a little bit here. So in order to maintain that 50 voltage drop across this reference resistor, the output has to be negative 50 volt. So if you are to put that back into calculation, we said voltage gain is what? On inverting amplification, we have the reference, the voltage that we have is negative 50, right, at the output. Voltage out divided by voltage in is going to be negative 10. So that's where the calculation is coming from. Hope that makes sense. If it doesn't, you can just replay the video and send me an email or whatever that I can help you out. Okay, thank you.